So for today's lesson, what we are going to do is we are going to add and subtract rational expressions that don't have like denominators, no, that do have like denominators, sorry. So these are with like denominators. So recall that when you add and subtract, you must have like denominators. Okay, and when you add or subtract rational expressions with like denominators, all you need to do is add or subtract the numerators, just like you would with a basic fraction. That answer gets written over the common denominator, and then if you need to simplify. That might be something that you got to factor before you can do that. So when you add or subtract and you write in simplest form, for this first particular one, you've got common denominator of a 7. So your 7 gets written over down as your common denominator, and 5x's plus 2x's just give you 7x's. Well, now you're back to having stuff from a long time ago where 7 divided by 7 just is going to cancel out to give you a 1. And the answer ends up becoming just plain old x. Take a look at the second fraction. Common denominator is an x. Well, 3 plus 5 is 8. Nothing can be simplified here, so this answer is just 8 over x. The next one, the common denominator, is just 3m. But now this problem is subtraction, so you need to remember that subtraction is either keep, change, or because it's just a mono minus a mono, you can just say 7 minus 4, which you know is 3. And again, you need to simplify this. 3 divided by itself is just 1. And so your answer is with m on the bottom, which means it's going to be 1 over m. 4, very much the same. Your common denominator stays as is. Your numerator, you don't have like terms, so you're going to have to write 2x plus 6. Well, if you can factor something, you do. And here's the first time where we've seen that the top is able to be factored by GCF. So 2 is the GCF, x plus 3 is left over. This common denominator is a binomial, which should always be written in parentheses. And then you should notice that the two binomials cancel out, and this final answer is just 2. Let's take a look at the next one. It's addition again. Common denominator is 3x plus 2. Nothing can be factored here, so I'm just going to put that automatically in my parenthesis. But on the top, when I look for my like terms to combine, you've got a couple of sets of x's. You've got x plus 5x. So this becomes 6x, and then 1 and 3 become 4. Well, you can factor that numerator by a GCF, and the GCF is a 2. What's left over is 3x plus 2 over your denominator. Your denominator is a like term with that GCF factor up there. And this answer happens to also be 2. Take a look at the next one. Here you've got subtraction. You got to be super careful here. So this has got the common denominator of x minus 1. I'm going to put this in parentheses because I know it can't be factored. But when you do subtraction, you need to remember that you're subtracting everything in that second polynomial. So I'm going to write this a little bit differently. I'm going to say, okay, my first polynomial, my first numerator is x squared plus x. I'm subtracting this whole second polynomial, which is x plus 1. And if you remember, keep, change all, right? Keep, change all. It really turns into adding a negative of x and a negative of 1. So now when I combine like terms, there's only one x squared, and I'm going to keep that as is. So the x squared just stays as x squared. In terms of the x's, I've got this right here. I've got this positive x and this negative x, which cancel out. And then what's left over becomes this negative 1 that I have. So this becomes x squared minus 1. Make sure you're okay with that. It's like doing keep, change all, and then combining like terms. Well, it turns out that I can factor that numerator. It's a dots problem. X minus 1, x plus 1, over x minus 1. These are common factors. And your final answer is x plus 1. Here's one more. Number 7. Again, it's subtraction. The denominator stays as is, y squared plus 8y plus 15. That should make you think it's an I. It looks like an IM and it is an IM. Up top, you've got to be very careful because you're subtracting that whole second polynomial, which means you're going to be adding the negative of y and the positive of 10. When you combine like terms, 3y minus y is 2y, and then it's going to become 2y plus 10. You can factor both top and bottom. Top by GCF, 2, y plus 5. Bottom by IM, y plus 3, y plus 5. The y plus 5s can cancel each other out, and your final answer is 2 over y plus 3. So subtraction, you got to be super careful that you do keep change, change all. I think that's it. So then there's your worksheet. So just be careful with the worksheet and you should be all set. Good luck.